There we go. So, this line of text. Went looking for a problem today, and I mean, I've talked about this before, but I had not seen this line, and like I just noticed it, and I hate it. Why is that? I need to back up and provide context. I know. I guess I wanted to start off by saying this line is what the stream title is about. They say support uniform scale, I say support non-uniform scale, and we'll get into what that means. Because what that means is relevant to animation. So somewhere here in the jump animation, what I wanted to do is... Wow, that's a kind of a short thing. I guess like that. Want to do a Y scale. Wow, that is really... Yeah, something like that. And so what this does is it's a little bit of stretch and squash, which is very hard to see in real time. I definitely got it wrong. Okay, that's a little better. So what I want, and let's actually show the runner, and what we had in the previous game and all, is a slight squash effect. You know what, I will make the squash more pronounced so that you can see what's going on. But yeah, you squish down and then you bounce back up. And it's like a little thing, but it's actually as far as animations go, it's pretty much mandatory. It's one of the fundamental principles of animation is that characters and objects should stretch and squish, especially if they are even remotely soft. Like if they're not supposed to be soft, sometimes you can get away without it, but like even like a solid rock in some cases looks better if you stretch and squish it based on motion and impact. And I want to be able to do this, but I actually can't. Because Away3D doesn't support it, and the game renders using Away3D. And I mean, they recognize this as a problem because they have a to-do that's the words to do. It's a note that you leave in the code when you don't have time to like make a feature, and you gotta leave it for later, and that's okay. The problem is this word, uniform. What uniform scale is when everything X, Y, and Z all scale together, and that's not an appropriate animation in the slightest. And if they only support uniform scale, then there will be no way to actually do the correct animation. The correct animation being that you squish into the floor, and that's exaggerating it a bit, but I'm going to keep it exaggerated so that you can clearly see. Like, it should be obvious that you're not supposed to compress like that when you land. I'm struggling to put it into words a bit, but I feel just the difference. This looks about right, whereas compressing like that is just not right. But uniform scale means this is the only option if you want to squish, is to squish along all three XYZ axes. And that's kind of why I hate it. They recognize that there is something to do, something that needs doing, but they get it completely wrong. This uniform scale is not is no more useful to me than lacking scale at all, because yeah, so, okay, getting to comments and questions. Bobby asked, can you not change the actual dimensions of the character during the animation? At the moment, no. What you see here in Blender does not show up at the moment. Even if I have a squash, even if I told it to squash like this, when you put it into the game, you get no squash. And I tried to work around that. It's worked around it okay-ish, but it's just not the same. I need to be able to do this. So yeah, it's not a feature yet. That's a problem. They recognize it's a problem, but their solution is bad. Let's see. Chris asks, for the next runaway stream, am I going to speed up the runner so that we can see the tunnel building? I'm in terms of building the tunnel, I think the current solution, which I think I should just be able to compile and show you. Zoom out just a little. When I there's a bit you can do, something I did, which is in between levels. You speed up massively, and we're going to put some features in between there, but speeding up massively does mean you can catch up to where it's still building. And it's not the only option, but it's an option. And like, I'm going to give it a little more time and effort to like see if it will actually work with, you know, features in between levels so that you can see where you're going. You can anticipate coming up to the next level. Yeah. So this is a work in progress, but I'm working on that, and if not that, I'll do some other ideas so that you can see it building. Let's see. Next. Tiny Runner, also known as the child without a balloon. Yeah, kind of, though do note that the arms, legs, face, nothing else scaled. It's, and I could make it scale, but actually I need to make the face scale. I don't think I want to make the arms and legs scale. I'll work on that. changing the timing of the animation would affect the feel. Well, sure. I'm not worried about the timing here. I'm worried about the ability to do certain animations. That said, I do need to update a lot of aspects, including timing, because the animation I've got for running feels more like walking. So that's a later stream. Let's see. Roshan subbed to me for Brawl Minus, and all of a sudden it turns out I'm the dev for the Run series. Yes, I am. Glad you like both things. I worked pretty hard on both, to varying degrees. Okay, and I caught up. Excellent. Yeah, so hopefully that introduces what I'm gonna try and do. I don't know that I can fix or finish this stream, but gonna give it a shot. So I had identified this class as the source of the problem previously. The thing is that for each joint pose is the class name here. So each joint is these things. Bones, joints, there are a couple other names. They represent how different pieces move, and you can rotate them to... oh no, I've got symmetrical editing turned on. Okay, so yeah, you can rotate these to affect the model and do animations, and it's cool. And you can move them to move the model, or pieces of the model, depending on which one you move. And that is pretty great for animating. But in Away3D, you've only got orientation, that's rotation. A quaternion is a way to store a rotation, and a translation. So that means you can rotate and you can move, but you can't do anything else. Specifically, you can't scale. You can't scale that way. Can't do a I was thinking yeah, I don't know. You could I guess if you mess with multiple of these at once. No, you can't. Okay. Well, you can do some interesting things with scale, I don't know, if I wanted to stretch out the antenna, that would actually be a scale operation, and other things. But it doesn't have that, it doesn't store that information. This is where data is stored. It loads up the data from Blender, and it processes it, it stores it here, but it only stores position, it only stores rotation plus position, and it just sort of deletes and or forgets about the scale. And so that's at least where I'm going to start. Oh, and as long as I'm actually editing the class, I am going to fix this line. We're going to support non-uniform scale. If we were supporting uniform, we could store a number. That float value represents a number, and just use a single number for x, y, and z. Just use the same number. But we're not doing a single number. We're doing a vector, which is the main thing about a vector is it's three values, x, y, z. And I guess the default is a scale of 1. Okay, that's a weird way to do this, but yeah, the next step is just to update as many things as we can to use this scale value. And we're going to include some useless documentation because half tempted to delete the documentation because it's so useless. Like at least this might explain something. Yeah. Anyway, not. So I don't know if this function actually is ever used, but it's good to have. Yeah, we can make one joint as a copy of another. I don't know if that's important. We copy the scale into a matrix when they make a matrix. And I wish it was as simple as that, but I have actually already checked, and there are other points in the code that use this data, and we need to find all the places in the code that use this data and make it also use this data. Okay, that said, before we go searching through more parts of code, I'm going to get to comments. I don't understand why quaternions are used for rotation. You should only need 3 numbers. One for direction, one for inclination, one for spin. Yes and no. It is possible to define an arbitrary rotation using just these numbers, but it does not work so well in specific cases, like very specific directions. And I actually ran into that problem in a different stream where when the camera's rotation, it was camera rotation, was very close to one of these specific rotations that was a problem, it would slow down and then suddenly snap into place because it couldn't quite represent the values in between. Like it would jump over some values because it couldn't accurately represent the stuff in between those. Which, not perfect. Also, like there are a couple other issues. If you want to smoothly rotate between point A and point B, and you try using Euler angles, that's what the XYZ, direction, inclination, spin, yaw, pitch, roll, whatever you want to call the 3 numbers. The 3 numbers are called Euler angles. If you use Euler angles, you're not going to get very good, very smooth rotations between, like, I don't know. Actually, I have animation tools. I can show you an animation. Yeah, okay. So, just insert that. Let's say that we have a rotation of that and that. And I don't even know what I'm doing. I don't know if this is going to be a good example. So, okay, starting here. Yeah, I mean, that sort of works. It would have to be a more extreme example, I guess. As the runner does flips. But, yeah, there's just something... you can end up I don't know. And I bet it's even worse around one of these gimbal lock points, as I guess they're called. Which, yeah, so... okay, so I guess the thing is that sometimes, if you're in exactly the wrong coordinates, if you want to rotate from like this to this, what you will actually end up doing is rotating. You rotate forwards, you spin around, and then you rotate back up, just because the numbers are not precise enough. Anyway. Having the extra value that quaternions give you and the different way of calculating the math makes a lot of operations just more accurate. Yeah. Okay. So anyway, that was a fairly complicated question. I'm not an expert in the answer. I would look up gimbal lock, Gimbal lock, and find someone else to explain it better. Yeah. Which is why I'm kind of sad that Away3D doesn't use quaternions by default, because it would be really nice to just represent all rotation as a quaternion. But whatever. It is, I admit, much easier to define rotations using XYZ. But not usually defining them in code. Okay, so next question. Okay, everybody's talking about brain damage. Yeah. So yeah, short version is there are complicated math reasons why quaternions are better that even I don't fully understand, because it's well, 4 values in a quaternion means we're working in 4-dimensional space and you can't really visualize it. So, yeah. Also, matrices have 16 numbers, and they're pretty complicated too. So I never know whether to append or prepend, or what order to do things in. It does often make a difference, but not that big a difference. It's probably fine. Anyway, I'm going to go and try and do stuff. Specifically, I want to find where joint pose is used. Well, more importantly, I want to find out where orientation and translation are used. Skeleton animator. This seems like a place where it's used. it's also a lot of math, which is unfortunate. And they use bad variable name. Well, okay, I can't call these bad just because they're not what I usually use, but I don't like when people use variable names that are just one letter, because when I come in and try to understand the code, it takes just a little bit longer to parse the what they're talking about. So my plan for now is just whenever these other things come up, I add scale. So I just like copy paste and change translation to scale. Q Q Q Q T T T S S S. Yeah. Yeah. I as I was saying, I agree with Bobby on this. If it's just one letter, like, yeah, some iterators that's good for. I don't like it when it's this, but I'm also not going to change everything how Away3D does everything, and I'm not going to quote unquote fix the name just for one variable, because then it sticks out. Why is one variable a full word and all the others are not? No, I'm matching the style that they already used. Okay. Okay, now this is worse because x2, y2, z2, w2, x1, y1, z1, w1, x2, y2, z2, w2, x3, y3, z3. Wow, I did not even look at those. These are way worse. I have no idea what they mean. They don't even have, like, I get that XYZW is going to be a quaternion and therefore a rotation, but an XYZ is probably going to be the translation. But why do they have to be numbered instead of... Yeah, W1, W2, X1, X2. They're doing quaternion math, aren't they? Oops, that's my class. This is their class. Yeah, they have a bunch of functions for this. Okay, so my plan here. I don't. Yeah, I hate everything about this. This is totally unreadable code. They're using it for something or other. My plan is to figure out what they're using it for, match that up with a function in here. Like they're doing a math equation, I want to find the equation. And then I will replace it all with a function call. If there isn't a function call, okay, append parent orientation, that should be multiply. W1 times W2, X1, X2, Y1, Y2, Z1, Z2. Actually, you know what, let's... I just want to double check that these are identical lines, which actually I can do. Yes, they are identical because Git does not see any difference. So they actually copy-pasted this function out because they thought it would be faster, which, to be fair, it is slightly faster because the function isn't inlined, but in the process they made the code totally unreadable. And that's awful. I don't know if I can safely make this inline, so the way I'm going to fix this is temp is also not a great variable name, but I don't like. Maybe I'll figure out a better name as I decipher what this code does. Okay. Yeah, responding to Bobby, I don't completely understand quaternion math. That's why I have a class for it. Like, I know I said I made a class for it. Like, I did make my own class for it. I copy-pasted other people's math into that class and made sure it worked without understanding it, and then left it there. So, like, I copied other people's work. Yeah. That's honestly what like, I think the recommendation for quaternions is don't worry too much about understanding them. Just have a class with function names you can read and call those function names, as in, don't do this. Don't do random quaternion math with no explanation. Have a function with a name that shows you what you're doing. I am not going to copy this documentation because it is useless. If you want to figure out what the result of this function is, you need to look up the Wikipedia page on quaternion multiplication. Though, yeah, fills the quaternion object with the result from a multiplication of two quaternion objects. That tells you nothing. I know that multiplication is sort of an append operation. That means one object represents a, let's say, a 90-degree rotation around the x-axis, and the next is a 90-degree rotation around the y-axis. Multiply will combine those and get you a rotation of one followed by the other, or sometimes the other followed by the first, like depending on what order you multiply in. And you can do much more complicated things, like you can rotate in that direction and then add a rotation in that direction. And it'll figure out where the exact... now you're looking this way and you're sort of tilted sideways. Yeah, it'll figure out all of that based on it's a lot of numbers, but this is a quick to calculate formula. This is From the computer's perspective, this is really fast and simple. But the word multiply doesn't normally sound like that. It's called multiply because you're multiplying everything. W1 times W2, X1 times X2, Y1 times Y2, Z1 times Z2, yeah, all of that. And it might be a matrix multiplication. I don't think it's matrix multiplication. It's anyway, that's kind of the fundamental operation with quaternions. Multiply vector, that's an annoying name, but whatever. Yeah, so it would be nice if this function actually explained that multiplication is when you combine two quaternions, combine the rotation. But, oh well. Okay. Viewer questions. Am I trying to convert quaternion to my own quaternion? I'm not worried about my own quaternion class. I got this class here. It is less convenient to use, honestly, but it's inline and actually, I guess that's the main benefit. It's inline and it creates fewer objects. I've never been clear on whether that actually matters. Okay. Multiply. Yeah, anyway, I'm not... I copied over their function so that I could inline it because they are apparently worried about performance. This might be a function that is called all the time, which is why they did this. To be quite honest, this is also pretty much nonsense. Hax, the language we're working in, optimizes for this, so like there's a reason that people do this, but it's a in this programming language they don't need to. It's not recommended. See, another question. What am I doing again? I am fixing this class by adding a scale value. And as part of fixing this class, I am cleaning up some of Away3D's code because this code is completely unintelligible and there is no reason for it to be completely unintelligible. It ought to be fine. Wow. Listen, look at this. Pose.orientation, they store that in the variable OR. And then copy down all the values out of the variable OR. So that's equivalent to this code, just like a little more concise, and I think they think they're saving time by not doing pose.orientation. But seriously, computers cache data. They say, hey, you've retrieved data from pose.orientation literally 0 milliseconds ago. Yeah, we still have that information right here. You want the Y value? There it is. You want the Z? Like, there's no reason to actually copy that down. I'm sorry, just... Away3D is nice overall. It does a lot of stuff, and if I were to have implemented it myself, I would be still working on it in 2030. They got it done, and that's ultimately what matters. They have a working system that's much better than mine. I just take issue with a couple of the ways they did things, and I'm gonna tidy it up as I go, a little bit at a time. Because honestly, all of this is unnecessary because oops, I hit the wrong button. Where'd it go? Okay, we are going to do that. Honestly, no, we aren't. If this causes performance issues, I will just inline this function, which they probably should have done from the beginning. Okay, so let's just look at this. This block of code is identical to this block of code, so we can replace all of this with a multiply call. We just need to figure out what QA and QB are. So the first input, which is W1, X1, Y1, Z1, is based on OR. So, and the second one is based on X2, Y2, Z2, W2 is based on pose.orientation. Boom. You can actually pretty much understand that. But we're not done. OR is parent pose.orientation. And oh, it is used. Okay. So OR can be replaced by parent pose.orientation. So now we have a line of code that if you know what multiply means, you can actually understand the line of code. Q is the result of this operation. Q is what happens when you multiply the parent pose's orientation with the current pose's orientation. And what that is something, let's look at these antennae. This is the parent of this, which is the parent of this. And each one, their rotation is applied to their children. So this one, if you rotate, all of them rotate. This one, if you rotate, only its child rotates. So this one doesn't, because this one has a rotation, this one adds a small amount of rotation to this one's rotation, or I guess it multiplies. And that's how you can set up, I want to be able to rotate this and have the others that are attached to it rotate, but the ones that aren't attached to it not rotate. And this one, which is the parent of everything, makes everything rotate, whereas you can rotate just an arm, just a leg. It's necessary. So yeah, this function simply combines the two rotations and stores it. Great. Append parent translation. So I'm going to need to figure out which function that is. It might be multiply vector. No, it's not. Is it this one? Minus W1, X1, minus Y1, plus 2. No, well, it's looking like it's similar to this, but there's more going on. So to start with, I'm going to simplify by removing that from the equation. So first we do something, we rotate a point. I think we're rotating a point at least. And then we add a point. So that means we because the parent's position also affects the child's position. So this antenna, the whole thing moves when the parent moves. And I guess this one's position is also based on the parent's rotation. That's probably it. Bobby asked, what is inlining a function? Inlining a function is something to make the code run faster. When you inline a function that we actually call, all the way up here, I type the word inline. Now what happens, when this is compiled, that line is replaced by this code. Like in an early phase of the compilation process, where W1 is, except that instead of QA, we type parent pose.orientation. It makes it a lot longer and less easy to read, but that's fine because no one actually looks at it. It just gets compiled further. Usually no one looks at it. And QB is going to be replaced by pose.orientation. Not quite literally, it's a little more efficient than this, but this is the explanation. And then yeah, so because of this word inline, it does not perform a function call, which is a little bit slow, and instead it runs the code that was inside the function with variables updated, which means, well, short version is that's good for performance, but and it's kind of like typing this out. They had typed it out already. It's kind of like that. But, well, my complaints about that were it's really hard to tell what's going on. So instead of not being able to tell what's going on, you can have this function call, which is a lot easier to read, as long as you know what multiply means and parent pose and so on. You understand that, you can read the line. And then when it gets to be compiled and run, you get the fast version of the code. So you get kind of the best of both worlds in terms of performance and readability. Yes, it turns function calls into code blocks. To clarify, every component has 7 numbers. By component you mean joint pose, or every joint. They actually, well, yes, at the moment. I hope I didn't change anything there. But I'm adding 3 more. So yeah, previously there were 4 in the quaternion, 3 for the translation, and I'm adding 3 for the scale. because, yeah. Why isn't every function inlined? The main reason is because, well, A, it's not always possible to inline a function if you do stuff like recursion, or a couple other stuff, a couple other things, depending on how you use the return keyword. Sometimes you can't. Other times, replacing this with a code block and replacing this with a code block and replacing this with a code block and this with a code block and this with a code block, you would end up with just a lot more code, which your computer can run, but that code does, like, it's the equivalent of text, but text can add up eventually. You increase file size by doing this, so it's a little bit of a trade-off. I have no idea what's a 50% chance, sorry. Maybe that's why they didn't inline it, but I don't know. I kind of go with intuition. The shorter the function, the more likely I am to want to inline it. Like, I would not inline this. That's a bunch of code. I don't want to copy it 50 times. But inlining this, maybe you could copy it 50 or 100 times. That would be so bad. That could probably be inlined. That's not all that much code at all. I would not inline that, yeah. But bit of guesswork there. I was going to say art form, but honestly I get so little feedback on it because it's a subtle difference for the most part. Okay, so I was trying to figure out what this is, because it looks a lot like a bit of code over here, all the way down, I think. Yeah, it looks a lot like this. Oh. Let's group the code a little differently. This block looks a lot like this. Is that right? Minus x times x minus y times y minus z times z w times x y times z minus z times y time w times y minus x times z, z times x, w times z, x times y, minus y. Yeah, I didn't have to look at all of them, but yeah, they obviously copied this and changed the names of stuff. So I don't think I'm gonna inline this. It's a little bit more than the amount of code I'm comfortable inlining. But if there's an obvious slowdown, maybe I will. But instead, I do need to figure out, so x2 is x2, yeah, so number 2, which is going to be temp 2 now, though actually I think I won't even need the temps. X2, Y2, Z2 come from OR. So, we're doing OR.rotatePoint. Because this value here is the equivalent of this value here, which is the the quaternion instance that you're calling the function on. Hopefully some of you understand that, because I'm not explaining classes and instances today. I don't have I don't have that kind of time. Yeah, anyway, what I have figured out is that this x corresponds to this x2, which corresponds to OR, which means that OR goes here. W1 corresponds to a temporary value. Okay, I don't even need to worry about this. They make the temporary value for me. I do need to worry about x2. Yes, x2 corresponds to vector.x. Vector, oh no, this is even worse. They copied it, and this x2 here is this x3 and not this x2. Okay, that's annoying. Okay, so x2 on the right represents x3 on the left, and x3 on the left represents tr. So tr on the left represents vector on the right, so tr goes here. And then finally, target. Wow, why? Can you not take up the... Thank you. Target. Oops. Target is here. It is the thing at the start of this, which is t, which means that t is our target. And this whole bit of code can be condensed down to orientation.rotatePoint tr, t. And that can further be condensed. OR is that. TR is pose.translation. Actually, maybe I'll keep that. And T is our output. So we'll get to the output later. So we no longer need those. And we no longer need that. I guess we put that there because it was, in theory, connected. Okay, maybe it's there. Rotate point. What point are you even rotating? I'm spelling it out. I want to be able to read this code. Caching should be fine. Not going to lose a whole lot of time on that. So yeah, I'm not going to do that. So do we still have an x1 or x2 or x3? Excellent, okay. We can get rid of all those temporary variables. Hang on a second. Let's... I just want to compare this side by side. Red is all of the code that we deleted. Green is the code we replaced it with. So instead of all this, instead of all that, we have a single line. Instead of typing all this out, we have okay, I guess these 3 lines at the bottom kind of stayed, but they're a lot simpler. Oh, but I messed it up. I do need to write correct code. That's important. It should work the same as before. Though I can double check that, yeah. It should actually just work the same as before. With a scale of 1, which is no change. What is the difference? The difference is that I can now understand the code. And the runner's animations look quite normal. And the runner, yeah. Physics glitches are the same, but... yeah, mid-air jumps are a temporary thing, don't get used to them. Yeah, so it works the same as before. Told you, match up the function and you can read the code. Aha, T, Q, and S are our output. They are being added to this global joint pose variable, which... okay, taking bets. When I mouse over global joint pose, will I get any useful documentation? I'm guessing... oh, wait. No, I won't. It's a local variable. Yeah. Okay. I can't blame them too much for that. Global poses, though. A flat list of pose objects that comprise the skeleton pose. I mean, that documentation's fine. Okay, so target pose, yeah. Target pose is T, Q, and S represent values in target pose, and we're updating target pose, so do we have good documentation there? Skeleton pose object that will contain the global pose converts a local hierarchical skeleton pose to a global pose. Yeah, I think that documentation's fine. Much better than some things. If parent index is less than 0, that means this is the top one. Question. Is there a copy from function? Yes, there is. And it also 100% should be inlined. And how much do you want to bet there's a copy from here? Mouse over it. Yup. And it's also not inlined, is it? It's not. They have something against inline. It doesn't really make that much sense. I won't touch the vector class here or now. Though... oh. There's no function for that. Okay, whatever. Yeah, we are so close to being able to delete some of these poorly named variables that I'm going to go all the way and delete them. Global pose is a local variable because this function is about creating... Yeah, in this case, global means it refers to a coordinate space. So... yeah, I've kind of explained coordinate spaces before. They're related to parent-child relationships, and earlier when I was talking about this causes the others to rotate and also move, it's kind of as if this defines a coordinate space where its child exists within. So envision additional axes, like instead of an axis going straight up and down, an axis going this way along the parent's direction, and then x and y axes instead of forget about the x and y axes. Yeah, the fact that this defines a coordinate space means that if this had 0, 0, 0 rotation, so no rotation at all, it's not pointed straight up in, like, the world. It's pointed straight up relative to the parent, because the parent defined a space in which up is this diagonal direction. And that's great. It's nice for calculating, like, it's nice for setting up the rotation, but eventually you do need to draw it on screen, and when you draw it on screen, it needs to be diagonal. So you need to do some math to convert. Hey, this is straight up within the local space, but it's actually diagonal on screen, where screen coordinates are global coordinates or scene coordinates. There are a couple names for it. So local to global is a common sort of thing that you have to do. Yeah. Global poses being a local variable makes sense to me. Okay, I'm just looking at this. There, Q and T. Q is named because the orientation variable is a quaternion. T is named because it's a translation variable. It's not V because it's a vector 3D. Like, one of these is based on the variable name. The other is based on... one of these is based on the variable type. Its type is quaternion. The other is based on the variable name, and not the type, and that is annoyingly inconsistent. So... I have very little reason not to just delete and replace these. So Q goes there. T goes there. S goes there. And T also goes there. And there, but again, there's caching. The computer will be perfectly capable of caching two things at once. And now we can delete the inconsistent variables. That's a little bit long, so we're going to shorten it. And I feel it makes sense to shorten it because in a list of global poses, you get one of them and you get a singular global pose. Literally no other variable here spells out joint pose. Except, I guess, this. For consistency, whatever. I'll leave that one. So, I don't know. The lines are longer, but they're longer in a way that makes them readable instead of a lot of meaningless numbers and letters. We're putting this data into the global pose, and that's what the output is going to be. Am I going to test all that code? I mean, sure. Not thoroughly, unfortunately, but if it can render an animation correctly, it's pretty good. And in fact, it can render an animation correctly. Multiple animations, in fact, and transitions between those animations. And just the fact that it can render this animation correctly means that it is... there are like 20-some joints in the animation, all of which are updating. I think we're at 60 FPS. So 60 times a frame, it's updating 30 different joints correctly, which I'm not testing every possible use, but I am, like, this code is getting run, this code is getting run, it all seems to be working. So I think it's fine. So the one thing is I need to add scale here. That's my original quest. I add scale, and then every time we get a pose.translation or pose.orientation, we add an equivalent pose.scale. So or do we? Okay, so actually, I just realized most of these, like in Blender, I deliberately turned off appending the parent joint scale, and I guess I can show you what it looks like if I don't turn that off. These are going to be a lot of... it's going to take a little bit, but could be worse. Here, like this. So I have turned on inherits scale on the right arm and leg and nothing else. So now, if I scale the parent joint vertically, you can kind of see the difference between, well, maybe if I center it better. They both look weird, to be quite honest. But maybe if I'm a little smarter about it. Okay. Well, You know, it's probably fine to do that. It would fix a couple of other things. Okay, I can't speed this up. Is this a property I can animate? Wow. Yeah, so I think I'm going to do this, and the trick will be not squishing the antenna. And so, I'm going to mess with their scale so as to reverse the changes. 0.7. I want... Will Blender calculate that for me? It will. That's neat. Oh, but to really fix this, I need to do some shear, don't I? Oh, I know. I should be doing that. Yeah, I don't actually have the ability to do shear, but it looks like it mostly fixed them. So, okay. If I do that... if I do that, then the antenna will pretty much not squish. It's a little difficult, but not the worst, and it's a small price to pay for making the face fit on the body, as this all happens. Oh wait, no, it doesn't fit on the body because I haven't finished updating. Sorry, I have more. I have more of this to do. Okay, so yeah, you see the difference that it makes of the whole body stretching and squashing. It's a bit of a judgment call, but I think my best judgment is to enable it and maybe add an option to turn it off on a case-by-case basis. Sorry, just checking chat if I missed anything, because I haven't looked for a while. Did the runner go slower in level 1? Well, I don't know what you mean slower then. Still adjusting physics stuff. I want to... I kind of want to match... I want to match the original game's physics, more or less. So whether or not she went faster, I'll be changing that. Okay, and other than that, it looks like I missed talk of Who's Who. Hope you figured that out. Right, so the question was, do I append parent scale? And I think I do. And I think I have to type it out because, yeah, this is one thing that my code does that Away3D's does not, is allow you to call a function and update a thing in place. So I do kind of have to type that out, and it's a little bit extra. But should be fine. I think we're done here. Yeah, that will not have changed anything because scale is always 1, and 1 times 1 is always going to be 1, and that means nothing. So we're going to go back and look for more update skeleton pose. That sounds like an important thing that we're going to need to deal with. I have a function for this. It may or may not be too much easier. Man. I did say I was not going to re-implement all of Away3D, so I'm not going to even fix these variables. I'm just gonna do it the way they did it. So yeah, copy paste. Yeah. This all looks correct, it's just a bit verbose. Are they gonna stay the same? I don't know what they... Yes, exactly. Yeah, clarify the question and I'll answer it. Skeleton binary lerp state. What a name. That said, I understand everything except binary. I don't know what they mean by binary. Like, my guess is that it's between two things. I'm sorry, I need more clarification than the variable thingy. Okay, so like what I was talking about here, when I said 1 times 1 is 1 and it's going to stay 1, what I meant was that currently I could run this code, but there wouldn't be any scale. Okay. What is the canonical reason for the gravity being different outside the tunnel? Or is that classified? It's kind of classified. Yeah. I do kind of agree about binary and lerp. Like, my guess is that by binary they mean there are 2 endpoints, and they're not trying to do a more complicated interpolation between 3 endpoints. But, yeah. As for gravity, yeah, I'm not sure I'm ready to answer that one. Okay, actually, what kind of skeleton NRE lerp state? Okay, I was correct. Yeah, it's binary as opposed to NRE. So yeah, it's 2 as opposed to a bunch. What do the alien skeletons look like? Yeah, what we're calling skeletons as far as animation goes is not what's actually inside them. It's just how we animate them. End quad and translate. They're doing the same thing, except at least they're spelling out multiple letters of the thing, but Q for quaternion, TR for translation. One of those is an actual data type, and the other is the meaning of a data type. Ah, well. It's far from the worst problem in this code. I don't think I have confirmed any bone, much less 5 bone, yet. Well, when in Rome, do as the Romans. The arms are kind of like flippers. Huh. Yeah, you can just do this for quaternion interpolation. Okay, so this is exactly what I was talking about when I was trying to say sometimes when rotating from point A to point B, you'll take like the long way around if you just use 3 numbers. With quaternions, you can go straight from A to B, and it will rotate correctly. And I promise that's what this code means. Where do they calculate these weights? Blend weights. Oh, that's where. Fair enough. I just hope they normalize that. I assume they do. Sorry, how long have I been going? Over an hour. Okay. It's not going to do a super long stream today. Probably. Which also means that I don't think I'm going to get through all of this. But we'll see. Yeah, so the age-old Roman problem of models not scaling. Yeah, that was definitely a big one that I remember from history class. Yeah, I'll keep at this, and if I have to get back to it, I will. I actually don't know how many of these I fully need to update. Oh, well, no, I still do have a bunch to go. That said, I might be done here. Yeah, that's the only one we need to normalize. I do want to double check my code here because I don't want to miss a thing. Aha, I missed a thing. Okay. That's the sort of thing I didn't want to miss. Though I think it would have told me about it. So what are we doing here? Wait, wasn't I... thought I started on that. Maybe I didn't. High quality. Okay, yeah, same thing. Man, this is duplicate code, actually. It's like straight up copied. Except it might be in a different order, so maybe they retyped it by hand. I don't know. But really, yeah, if this is coming up multiple times, it could be a function within joint pose. It really, really could be a function in joint pose. Like we're... Yeah. Yeah, yeah. Not quite sure how I should do the documentation, but... that's not it. Here it is. That's wrong. How do they do variables? They don't include that. And I think there is a... yeah. So... I'm just copying their documentation for this. I kind of like this, but that is not so great documentation. So yeah, what have I just been messing around with? Yeah, so given that we're doing interpolation a bunch, we're going to make it a function. It's not an inline function, probably. Man, look at how similar that code is. I'm sorry, not similar, identical. Yeah, it's actually copy-pasted. That's a sign that you should refactor. So end pose, we don't need. That's this. Don't need that. Guess I'll keep those just to keep this code from going off the edge of the screen. Duplicate code is not like an error. It runs. It's okay up until you need to change something, which I need to do. When you need to change something, that means you have to go through every instance of the duplicate code and change it and make sure you get it right each time. And that's not great. It's much better. Common coding principle, DRY, don't repeat yourself. And so what I am doing is drying up this code, as in DRY, making it not repeat itself quite as much. And once I do this, it'll be easier to add in scale. Oh wait, I did add in scale. It will be easier to test whether scale is working, because if it's going to fail, it's going to fail everywhere. How do I know when to change it? I'm changing it because I need to do something that it can't do. That's when to change it. How do I know when to refactor, when to move everything in, like move everything around and make this a function? That's, well, the usual rule of thumb is when you have two pieces of code that do the same thing, turn them into one piece of code that does the one thing. And that's my rule here. Actually, I found three pieces of code. Like I found two. I said okay, whatever. I found a third. I said Enough. I'm not doing the exact same changes to the exact same copy-pasted code again. I'm gonna make, I'm gonna put it in one place and have it in one place to be reused. And that's not quite. Okay, fine. It's a little bit awkward, a little bit of copy-pasted code. In this one specific case, we want to run less code, so we do that. But otherwise, most of that code can just be replaced with a function call. Okay, fine. I will... duplicated code. Duplicated code is a problem that I want to fix for my own sake and others, but fixing it does not immediately fix my problem. Identical code is duplicated code. That's just using a couple different terms for the same thing. And the code I wanted to make, it's not equal, it's just, it's easier to make the code if I, if it isn't duplicated. Because if it is duplicated, then that's like a lot of places. I have this long list of places that I need to go make changes. But it could be a shorter list. So, yeah. So it's not really speeding up my work, it's just, if someone else comes along and needs to do something, they'll be happy if they don't have to change it in 10 places, if it's just one place. So... I don't know why this is necessary, but I will not question it. I'm not here to question it, I'm here to break as few things as possible. Oh, okay, this one is... I'm getting back to that one. Copy from is fine. Oh. This. Okay, this. Yeah, all this code is the same, and I had to Yay. Now it's shorter. It's less code. Oh, I'm sure the code is necessary. I'm not breaking the code. I'm just moving it. I want to move it without changing it. And like I want to move multiple things into the same place, into the same function. And a function can be called from multiple places, but yeah, a bit complicated if you're not familiar with functions. But trust me, I'm doing my best not to actually change anything about it, how it functions. Am I making Run 1 open source? Not immediately. I don't know about later on. What are they doing here? So it's almost the same code, but it's not quite. And if it's not the same, like, when there's something that's different, I can't do a direct replacement. Base diff. Oh. Ugh. I see. Okay, that's valid. It makes sense. I just... Man, do I need to make a second... Why does this exist? I guess someone might have a use for it. Oh, that's a bit annoying, but... In which case, I will just leave the not quite duplicate code. No, I'll just do that. Let me know what you think might have been. I mean, I can explain what, or if I wanted to spend more time, I could explain what was going wrong. It's short version is that particular class was a slightly different use case. This class I've already updated, but I think could be better. Okay, good. I was a little worried about that. I'm being picky, but yeah. I've seen bugs happen that way. No, that's not right. Okay, I think that's fine. So we should be able to delete all that because we're doing a different formula. When I can't wait for the stream to go on 20 hours, when I say that I'm not going to let it go on too long and then I just keep going and going. It's not the first time I've done that. I do think I'll have to stop in the middle. I should close that. Lets me see. Excellent. Wait a minute. I think that goes up there. Man, I'd kind of like to explain this, but unless you are familiar with interpolation, it's going to take too long to explain. I've streamed for 4 hours a couple times. I do try to cut it off around 4 hours because I think if I go over, YouTube starts deleting... I don't think it deletes the stream data, but it might delete the chat, live chat data. So where were we? Oh! This needs to go in here, doesn't it? Oh wait, it is in there. Okay, yep. Okay, we're fine. I think that might do it. Though I will need to double check my math. So, let's sketch things out. We have three numbers, three weights. 0.2, 0.4, and another 0.4. They have to add up to 1. And the idea is that these numbers are weights. And they each represent, like, a pose. So, yeah, this whole state is when you combine three separate poses together into a single one, and so you have a low weight for one of the poses and an average weight for the other two. And what we need to do here is pass the correct values to interpolate. So that the final value is the correct amount of each. So we start out with the first pose is going to the first pose is going to we're going to start with fully in the first pose, but then the second pose comes along, and weight so far. So on the first pose, weight so far will be 0.2. On the second pose, it will be 0.2 plus 0.4 is 0.6. And that means we're going to do an interpolation from, why don't we give these names? A, B, C. So yeah, pose A should actually make up a tiny fraction of the small result. Specifically, it should make up 20% of the final result. Yeah, unfortunately, I'm actually not prepared to test this, so I had better get it right. So pose A, we start out with pose A being the whole pose, 100% pose A. That's not what we want. We eventually want just 20% of pose A. But we start with, which is why we keep working on it. So then we get to pose B, and we do an interpolate. And again, I'm not going to go into detail on what an interpolate is, but the short version is you mix some of A with some of B. And we need to find the correct value so that you mix the correct amount. So 0.2 plus 0.4 is 0.6. But that's not the actual value. 0.6 is weight so far. The value we pass is weight divided by weight so far, which is B has a weight of 0.4 divided by 0.6. Should be 2/3, like that. Not. Yeah. Like, it's basic math. I should not need to do a calculator, but I don't want to make a really silly mistake here. So at this point, after the interpolation, we have 33% of A. Okay. So after step 2, we interpolate between the previous value and B, which means these are rounded values. Wow, why is it so hard to find the percent symbol? So on step 3, we have a weight so far of 1. Which is great because we want to add up to 1. And weight out of weight so far is 0.4 out of 1, or 40%, or 2/5 if you prefer. Okay, so we got to 33% by There we go. There we go. Okay, so interpolate 40% means we just, we straight up have 40% C. But we have an unknown percent of A and an unknown percent of B, and I'm about to calculate them. This unknown percent we calculate by, well, 40%, the rest of the pie is 60%, and so that's 60% of 67%. So B ends up at 0.4, or 40%, because 60% of 67% is 40%. And A ends up at 0.2, or 20%, because 60% of 33% is 20%. And these are equivalent to these. Like, it's just actually the same, written differently. So yes, I think this is correct. But I did want to work through a simple example just to make absolutely sure that the numbers came out. Yeah, I know it's... you gotta work with interpolation, blending, whatever you want to call it, tweening even, if you're an animator, before it becomes easier to keep track of this stuff. Mostly going through all of that was for my benefit because I want to make absolutely sure that this formula is correct, because I'm not prepared to actually test it. So, I think we're done here, though I will... I do want to go take a look at... we deleted a bunch of variables, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 variables, and we reduced these... I don't know, 20-some lines of code to 3 lines of code. I'm sorry, that's more than 20. 30, maybe 40? Approaching 40 lines of code down to 3 lines of code. Just... okay, 4 lines because we added one. Yeah, that's... And we double-checked correctness. It is, unless, like, there is the slight possibility of weirdness if you have very, very tiny values, but if you have very, very tiny values, then they disappear anyway. Yeah, overall, that is a tremendous success. It just makes this whole thing so much more readable, except for the part where this is weird and not immediately intuitive, to the point where even I, the person writing it, had to double check its correctness. But it's not totally unreadable either. And like, if you could understand the previous code, you can probably work this one out too. And if not, you can see that it's correct, and it's like, it's not surprising. It won't be surprising to anybody that it's correct. I don't know if that actually helps. So, what's going on here? Generate difference pose. Oh. Okay, so this is where that other thing comes from. Wow, that's a lot of documentation. I guess it's that? Position, rotation. Okay, that's... Yeah, all I needed to know is that it went position, then rotation, then scale. So, yeah, it was actually easier to get that information by looking at the source code than by reading all this. Oh, wait, no. It was just as easy. The third vector 3D object holds the scale elements, which is number 2 because 0 indexing. Don't worry about it. Okay, so that was simple. Over 2 hours. Okay, this is straight up interpolating. Unless I'm missing something. No, I don't think I am. Boom. Yeah, same thing, fixed. Oh, weird. I've never actually worked with serializers. Neat. So yeah, let me just go through and see if there's anything else that's quick, because I think most of the other things here are going to take a while. Yeah, this... Oh. The stuff here that I have not done, this is going to take a while. Because, man, this is direct matrix manipulation, which is... might actually be easier than direct quaternion manipulation, but not by much. This is where I started. This I've done. This I have not done. Okay. Oh wait, no, I have. This is the one that I decided to leave. This I have done. I'm leaving the parsers, and this I've done. Okay, so I've done all the stuff I'm prepared to do this stream. Yeah. 9 out of 10. Sounds good. Okay. Excellent. I earned a 9 out of 10 on this stream. I think this is a good stopping point, then. I will see you all whenever I next get time for this. Hopefully in the next couple days.